So first of all, it's a pleasure to welcome you on board. So, as passionate people, we are always pleased to share with people like you interested in what we are doing.
Thank you.
And it's our operation are quite specific for our mission. So our mission is reproduce weightless conditions in the cabin. So we try to do that as accurately as possible. For scientific reason, the best is the 0G. The best will be the results of the scientific coming here, because this aircraft is a laboratory for space and a lot of science, as you could maybe you could see in the cabin.
Right.
Back to our operation. So we are flying at 3 pilots at the same time, in order to be the most accurate as possible, because we share the flying tasks in three, because each pilot will work on a dedicated axis, and we give the specific tools to this pilot to optimize the way we are flying the aircraft. For example, I will be in charge of the pitch axis, and you would be, the co-pilot will be in charge of the roll axis.
Yeah.
So for me to fly the aircraft on the pitch axis, so I will use that kind of stick that I fixed here, so that on the column,
Yeah.
so that I can only push or pull, but I cannot turn. So I can only fly the aircraft up and down. During that time, so I change, because we can do pitch and roll indifferently on the left or right seat. And now I'm flying from the roll axis. And with a very modern, the up-to-date techniques. Yes, all that it's not exactly certified, because there is no certification regulation, but it has to be qualified by the authorities. Yeah. So let us imagine that you are flying on the pitch, and now I am flying on the roll. And in order not to disturb my colleague flying up and down, I will use these ropes so that I can turn left or right, but you can fly up and down, and I will not disturb you, because it's free on this axis. No, we are changing. The most difficult and sensible is the pitch axis, because it's where it's the most difficult to get the zero accurately.
Yeah.
Zero on the lateral axis, GY, that's GY. You need to keep wings level.
Yeah.
That is not very simple, because the aircraft is changing the angle of attack, the speed, and the balance, the aerodynamical balance is changing. So you still have to work, but the target is rather easy to achieve in the range that you are looking for. It's less than tenths hundredths of G, 0.02. Yeah. No. All manual, and we disconnect the flying device to help the pilot. Yeah.
Yeah.
So mainly the pitch fill.
Yeah.
Yes, because the work is nicely done, but it's usual.
Yeah.
all the people are flying in the air and free floating in the cabin. So as soon as you have a little acceleration longitudinal, everybody will move towards the cockpit or backwards in the toilets, and we don't want that because you have no you have no contact of seats when you are free floating, and so it's important to keep also the zero on the longitudinal axis. That's why we have a third guy acting on the throttle to keep the zero, so that everybody stays at his place. We try to optimize the zero-G duration.
Yeah.
And it's a direct function of the energy you have at the time we initiate the maneuver.
Yeah.
So we target to begin the maneuver with the maximum speed.
Yeah.
So we are flying in medium altitude, flight level 200.
Yeah.
And we accelerate up to the maximum speed of the aircraft,
which is
340 knots, indicated airspeed.
Yeah.
And we initiate the maneuver at 335,
yeah.
accelerating. Then we call pull up,
yeah.
and the pilot begins to pull.
Yeah.
And we just come to 340 knots minus 1 or 2 knots.
Yeah.
In order to initiate the pull up
yeah.
to 50 degrees angle of pitch. We have a safety speed that we don't fly below.
Yeah.
But we work with the pitch angle. So at 50 degrees angle of pitch, the co-pilot is announcing injection, and then the pitch pilot begin to push in order to add the zero-G. We have between 120 and 140 knots.
120?
Yes, which is
so well below
the stall speed. Exactly.
Okay.
But there is no stall because there is no angle of attack, so no lift, so we're just falling down. So, so the aircraft is like a ball or iron. Or
okay.
No. Yeah, we have a specific training for what could eventually happen.
The worst failure, or
I'm sorry.
Engine failure, or isn't
failure
that much of an issue?
It's not. Yeah, we're training for that. A dual engine failure at the top of the parabola.
Yeah.
Because of fuel or something like that. But well, anything will continue to fall, and we will recover. But what would be catastrophic is if something, a forgotten tool in the flight controls, and that could eventually then fly in free floating, and as soon as you make the pull out, comes at the wrong place and will stick.
The controls will be stuck.
Yes.
Oh, okay.
So we have a specific procedure. Then we revert. We fly the aircraft with the trimmable horizontal stabilizer. Yeah. If it's nose up, the guy flying the roll make a 40 degrees angle of bank to help to recover down, pitch down. The pitch pilot full trim forward up to -3. And then we make the pull out with the pitch trim coming slowly up.
Okay.
And we train on the simulator, of course, to bring back the aircraft just flying with that, with the pitch blocked. Yeah. We use full power, maximum continuous power. Just before the pull-up, so that the thermal balance is set when we initiate, so we have the maximum power at the time. And the injection we reduce close to idle. It's not exactly idle, but it's the best position to keep the longitudinal acceleration to 0. It's nearly idle, but not exactly. Otherwise, it's negative.
Yeah.
Gx is negative, so we have to keep a little power And it is not easy to set because it's not, the regulation is not made to be very accurate in this range. And there is kind of what we call a fall effect. So if you decrease the throttle lever of 1 degree, you are losing a lot of percent of N1. So we use a special device to have just the appropriate position of the throttle there. No, this is an Airbus A310, which is technically absolutely standard aircraft.
Okay. Not being reinforced anywhere? Or
no. Just the maintenance procedure is special because making 1.8G0, 1.80 so is a little constraining, more constraining than an airline flight. No, we have no problem because we always keep the external tanks full. So, and we use the inner tank. After 2 hours of flights, the inner tank becomes rather empty. And sometimes we have air bubble that could come in the manifold. But the outer tank are linked to the manifold with a lower pressure than the inner, so that they keep full. But sometimes if they need to support the fuel coming from the inner, they always can bring additional pressure, so that we have no problem finally. That is part of the little modification that we put on the aircraft. We have changed there because as we move high range of angle of pitch, positive and negative, so even if you're in good condition, then sometimes with the pitch, the sun position, relative sun position is changing, and you may have maybe disturbed by the sun on the instruments. With deflection, and also as the shades are moving during the pull up and the pull out and the maneuver, so the shades are moving along your field of view, and it makes something strange in the human brain, such as vertigo, and so we don't need that. So we just keep the windshield clear, and we put shades on the side. No, we're not allowed because copolamine have secondary effects. That is not very good for flying an aircraft, driving a car. We are nearly, not all, but nearly all the pilots are former fighter pilots. So we are used to move up and down with aircraft. So. It is the right day to ask me this question because I performed my 10,000 parabole today. My first one was 25 years ago. And we have regular training and operating this aircraft. And the former aircraft was the A300B. I'm a former fighter pilot. I spent 18 years in the Air Force as a fighter pilot. Then I began a military test pilot. And a few years later, civilian test pilot for Airbus Group. And I flew something like 100 different aircraft, such as fighter, big aircraft, little aircraft, with propellers, with jets, or single pilot, or with crew. So it's very interesting, We have a training program. Well, first you need to have the type rating of the A310.
The A310,
and then we made some theoretical course to think about the zero-G flights, the limitation of the aircraft, how we fly it, and so on. And then we make some simulator sessions. And then we fly, the final flight and training is on the aircraft, and we made 4 flights, 4 training flights. There is 3 training flights and 1 test flight, which is used for training, and normally it's the pilot knows how to make the parabola in the acceptable range, and then it takes years to a the learning curve is still improving after years. It's never the same. It's always different, because there are very little details that are changing with the weather conditions, turbulences, or weight on the aircraft. Experiencing weightless for fun is sometimes we go in the cabin and we experience that. It's something so different than every other things. It's still pleasure. But our real pleasure for the pilots, I mean, is to fly this aircraft. As you mentioned, is all manual. And now flying an aircraft is a matter of flying a computer. And with this aircraft we're flying manually, and we're always targeting to do better and better, and it's very challenging. And we have a very little team. We're 8 pilots. And it's Yes, as maybe you know, during the last weeks we have very bad weather, often changing, and with perturbation coming from the Atlantic, as it is where we fly. So I was a little worrying of what we could find today, and our main enemy is turbulence and clouds. But that was rather clear, except some showers. But we could manage, and we have very calm air at the beginning, very light turbulence at the end, but very manageable.
Thank you
very much. Thank you
very
to
much.
come.
Thank you.
It was a pleasure.